Welcome to Models, Functions, and Permutations with Nora Charles,
Rebecca Armstrong,
Samantha Mary,
and Grace Carter.
First, we're going to be talking about functions and relations. A relation is any set of ordered pairs, and a function is a type of relation where each x value has only one y value associated with it. We know if it's a graph of a function if it passes the vertical line test, which is where a vertical line is drawn and it only intersects the line once. A composite function is a combination of two functions. It's shown by g of f of x. First one evaluates for f of x and then multiplies by g. In this problem, we can tell which one is a function. This is not a function because it does not pass the vertical line test, as it intersects the function here and here in 2 points. This is a function because it can pass the vertical line test, and it doesn't. And this is not a function because two x values are shown for different y values here and here.
Okay, so now we're going to talk about graphing. As you can see, there are 5 different types of graphs. Here we see weak positive correlation, which is basically, these are obviously heading in a positive direction. The points are increasing in value both on the x and on the y-axis. But there's a weak correlation because you can't draw just one point to define the line. Here we see a strong positive correlation. Basically, once again, these are going in a positive direction, but there's a much stronger line that you could draw to define this function. Here we can see weak negative correlation, which basically, same as the weak positive, there's not one line that you could draw, but they're instead going in a negative direction. And then here we can see a strong negative correlation. And then the last one, no correlation, basically means you can't draw one line to define the function because they're not going in a decisively negative or positive direction. So we know that for graphing, it's important that you be able to find the slope. So the slope is defined as the rate of change of a line, and a lot of times you'll see slope shown as m. So to find the slope, you need to use the equation y2 minus y1 over x2 minus x1. And this is also sometimes called rise over run. So we're going to do an example here. So if you have these two ordered pairs, right? 2, 2, and then 1, 9. You're going to take your y2, so that's 9, and then your y1, which is 2. And then do 9 minus 2 here, which obviously is 7. And then you take your x2 and then your x1 and subtract those. So you end up with 7 over negative 1, which is the same as negative 7. So your slope here would be negative 7. One more thing that it's important for you to know about is domain and range. So domain and range is just another way to talk about x and y values. So here you can see domain is just another way of saying x values, and then range for y values. It's important also to know how to graph slope-intercept form. This here is slope-intercept form, so it's y equals mx plus b. So in orange, we can see x and y, which are the ordered pair. In green, you have your slope, and then in purple, that's your y-intercept. So your b value is the same as your y-intercept. So here's an example. A lot of times when you're given this in problems, you'll be given the slope and you'll be given the y-intercept, but you won't be given x and y values, because obviously on a line there'll be more than one point that's going to fit with this form. So there are 2 ways that you can graph this. The first way, you can plot your b value, which is 2 here. So you go onto your y-axis and go up 2, and go ahead and plot that. And then you can use the slope, or m, which is in green here, to plot your second point. So we know that any whole number, so in this case 3, is the same as the whole number over 1. So the slope here is 3 over 1. So we know that the rise is 3, so we'll rise 3. And then the run would be 1, so we'll go over 1. So now you have your 2 points, and you can go ahead and connect those points, and then you have your line. The second way that you could graph this, you can plug in values for x, and then you can solve for y, and then plot those points. So in this case, we could plug in 1 for x, so you go 3 times 1, which is obviously 3, and then plus 2 is 5. So you would have 1, 5. So you go to your 1, and then go to 5, and it is still on the line. So that's the second way that you could graph. So now we'll do some practice problems, just to make sure you guys are confident on this. We'll find the slope of these 2 points, so 2, 6, and 7, 8. For some people, it's helpful if you go ahead and write out your y1, y2, x1, x2. You can do that if you need to, or if not, that's fine. You can go ahead and plug those in to your equation, so you have y2 minus y1, x2 minus x1. and then your slope turns out to be 2 over 5. This second problem, we're going to graph something in slope-intercept form. So you can see here that the slope is 2, which we know is the same as 2 over 1. And then your b value is 6. And since we know that the b value is your y-intercept, you can go ahead and plot that. So on your y-axis, you can plot 6. And then you can use your slope and go up 2 and over 1.
Now we're going to talk about vertical and horizontal translations. A translation shifts a graph either horizontally, vertically, or both. First is vertical translations. When k is positive, it shifts the graph up k units. So here are a few examples.
Just keep going, just keep going.
Okay, so y equals x plus k, y equals x squared plus k, and y equals the absolute value of h and k. When k is negative, it shifts the graph down k units. So here's a few more examples. So here's our first problem for vertical translations. So you want to translate y equals x squared plus 6. First, you want to plot the parent function, which is, in this case, y equals x squared, or it could be y equals x and y equals the absolute value of x. Second is to translate it up or down k units. And then the last step is to state the new translation. And here's what the graph would look like for our problem. And you would shift it up 6 units, and here it is. Now we'll talk about horizontal translations. When h is negative, it shifts the graph to the right h units. And here are a few examples. And it shifts the parent function, which is y equals x squared or y equals x, to the right. When h is positive, it shifts the graph to the left h units. And here are a few more examples. And you'd be shifting the parent function, which is y equals x squared or y equals x, to the left. And our problem for horizontal translation is to translate x minus 2 squared, and negative 2 is our h value. So first you want to plot the parent function, y equals x squared, and then you want to translate the parent function to the left or right h units. And here you see is the parent function, and we shifted it to the left 2 units because it is negative.
Okay, so now we're going to talk about permutations. So the definition of a permutation is just an arrangement of items in a particular order. So a lot of times you'll see problems with this done with words. So we're going to do an example here with cat. So obviously cat has 3 letters, right? So I wrote here at the bottom you have 3 options for the first letter of your permutation. Also, it's important to note that you can't repeat letters. You can have any combination of C, A, and T, but you couldn't have, for example, 2 T's and 1 A. So here you can see that we have 3 options for our first letter. So after you pick one of your options, you then go to your next. Obviously, if we pick C, that's eliminated for your second choice because you can't reuse C. So you now have 2 options. You can choose between A or T. So then, say we chose A, then you have one last option, obviously, because you've already used 2 of your letters and you only have 1 left. So you have C, A, and T, which obviously spells cat. So here you can take each of your options, so you have 3 options here, then 2, and then 1, and you multiply these together. So 3 times 2 is 6, times 1 is 6. And that's the number of permutations you can make. As you can see here, we have 6 possible permutations, which is a permutation is once again an arrangement of these letters or any item in a particular order. So a lot of times when you see questions with permutations, you'll see it written as a factorial. Factorial is basically the largest number of the permutation with an exclamation point next to it. So this one would be 3 exclamation point. And the way that you can read factorials and just permutations in general, so you always take the largest number. So if you saw 6 with an exclamation point, the largest number would obviously be 6. And then you multiply it by every number before it, going down all the way to 1. Obviously you don't multiply it by 0. So for example, if you had the factorial of 6, so 6 with an exclamation point, you'd have 6 times 5 times 4 times 3 times 2 and then times 1. So in this case, you would have 720 permutations. Permutations obviously increase exponentially by a huge amount. So in this one, it's a permutation of 3, and you have 6. But then with 6, you already have 720. So that's a big difference. So what about 2? So with 2 permutations, you would actually only have 2, because if you had something like A and T, you could have A and T or T and A. Okay, so here's a practice problem. So suppose you have 4 reindeer and you want 3 to fly your sleigh to deliver toys on Christmas Eve to Ashlyn. How many different ways can you arrange your reindeer? So there are only 3 slots in the sleigh, as we know. So obviously here are the slots. But you have 4 reindeer. So you have your first option. So you have 4 options here for your first slot. So you choose one to go there. Obviously then you only have 3 more reindeer left for your second slot, and then 2 for your last slot. So you'll take these options and multiply them together. So you have 4 times 3 is 12, times 2 is 24. So we have 24 permutations. And if we wanted to write this as a factorial, it would just be 4 with an exclamation point, because 4 is the largest number. So a practice problem that you could do on your own: how many permutations are there of the word llama?
Okay, so the next section that we're going to talk about is real numbers. And there are 2 categories of real numbers that real numbers can be split into: rational numbers and irrational numbers. And rational numbers, all rational numbers, can be written as a ratio of 2 integers. And irrational numbers cannot be written as a ratio of 2 integers. Then in the category of rational numbers, there are 3 different kind of subgroups. The biggest of those is integers, the second being whole numbers, and the smallest group being natural numbers. So a question that I just want you to think about is, what category or categories does -4 fall into? So here is how a chart would be set up of real numbers. So all of this that's here is a real number. Then it's split up into rational numbers and irrational numbers. Irrational numbers are numbers like square root of 2, cubed root of 6, and pi. Those numbers cannot be written as a ratio of 2 integers. And what are integers? So integers are rational numbers. And all integers are rational numbers, but not all rational numbers are integers. Integers are things like -2, -1, 0, 1, and 2. So it's a number with no decimal point after it. Rational numbers it can be 1/2, 0.3, -5, 2 2/3, anything that can be written as a fraction of these integers here. So then in integers, there's the category whole numbers, which is 0, 1, 2, 3, all the way up. But it does not include negative numbers. And then natural numbers is essentially the same exact thing as whole numbers, except it doesn't include 0. So these are like the counting numbers that you learned in kindergarten, 1, 2, 3, all the way up. So then the answer to the question that we had on that other slide is that -4 is real. Obviously, it's rational, and it's also an integer, but it is not a whole number or a natural number. Thank you for watching.
Thank you.
Bye.
Bye.